বুঝতে পারছো?
Yes, sir.
হ্যাঁ স্যার, ইয়েস স্যার।
ঠিক আছে, ওকে। Okay. Okay, so previously we have seen the definition of array. So now we are going to do the operations on array. Okay. Our first operation is our array insert operation. Okay. So array is what? Array is a contiguous memory allocation, and array is having a homogeneous group of data, means same kind of data is going to be held in a particular array. Okay, but here look in this particular example here, the array A, okay, array A is holding array A which has the size of 12, okay, because it's starting from 0, so 0 1 2 3 4 5 6 7 8 9 10 11, so up to 12 locations this array A is holding. So max location it can hold is 12. So that's why we have stated here that maximum location is 12. So max log is 12. Okay. Second thing we are checking that how many places among this within this array that is occupied. So if we start, if you can see here that from 0 to 7 means 8 locations of data are already occupied in here. So that's why we have written that n equals to 8. Number of places occupied within the array. Okay, because if we are performing an insert operation, there has to be these two things phenomena, that is the max location and the number of occupied place. Because if all the places are occupied, then I can't insert or we can't insert any kind of data inside there. Okay, any kind of item within the array, because the array is already fully occupied. So that kind of situation is called as overflow. See, so what is overflow? Overflow condition is when we are having some insert operation, but there is no free space left in the array. That type of condition is called overflow condition. So that's why whenever we are performing a insert operation, we have to first look out that whether there is any empty space within that array or not. If there is an empty space, obviously we can insert. But if there isn't any, we can't insert. So that's why that particular, if all the locations are occupied, all the places are occupied, and we can't insert any kind of any data inside there, then that particular situation is called overflow condition. Okay. Same thing is going to occur at the time of deletion operation. If my total, if I want to delete any particular data, or if let's say the array has been provided like this. Okay, these are the locations within the array. Our instruction is array, is not array, delete a data from 5th location, 6th location, 7th location, 1st location, 8 or whatever, XYZ location. That has been given to us. But we are seeing that the array is actually empty. There is no data within that array. So obviously we can't delete anything from there because that place is already empty. So that kind of situation when occurs at the time of deletion, that thing is called underflow. Okay, see, underflow condition is when we are having some delete operation, but there is no data to delete in the array. That particular situation is called underflow condition. So whenever we are doing our programming, always remember, whenever we are performing insert operation or delete operation together, we have to put a condition there of checking underflow and overflow. Otherwise, what will happen? The data will be, if it's not checking for overflow and underflow condition, at the time of insertion, if the data, if the array is in overflow condition, what will happen? That particular item is going to, either it's going to get rejected because there is no places to insert, or that place or that particular item is going to replace that particular data which was in that location. Okay, that is for the overflow condition. And the underflow condition, if you doing that thing, then obviously error message will return if you haven't put the underflow condition, because there is no data to delete. Okay, so that's why max location and number of occupied place is always important while doing any insertion and deletion operation. Okay, that's why we have found out max location is 12, number of occupied places are 8. Okay, here the condition has been given that I have to insert item number item. I have to insert an item which is holding the data 100 in the 5th location. Location equals to 5. So obviously 0, we are starting from 0. So 0, 1, 2, 3, 4, 5. So here at this particular location, this item 100 has to be inserted. Okay. Now look at one thing. Whenever array insertion operation or array deletion operation or any movement in array data holding is being placed, you have to remember one thing, that whenever if we are pushing this data item 100 here, what will happen? This 22 has to shift. So 22 will go on which side? Bolo? 22 will move on
Right
the
side.
right side.
Right side.
Yes, very good. So if we move right now 22 at the place of 3, okay, before doing the insert operation, what will happen? 22 will basically superimpose the data of 3. So that's why whenever we are performing any kind of insertion, deletion, movement operation within the array, the operation starts from the extreme right and extreme left. So see, this 2 is going to get moved in this place. Then the place for this is empty. So right now 6 can move here. So since 6 is empty, so 3 will move here. And since 3 is empty, 22 will move here. And then this particular location, our fifth location, will be empty. So whenever we are doing the insertion operation, deletion operation, any kind of movement operation, remember this one. The movement occurs like this one. We have written this one in pen and paper here. Look, our target location here. These are the target location. So this particular location 2 is moving where? 2 is moving from 7th location to 8th location. So that's why we have written from where to where. The movement is starting from 8 to 5. Okay? বুঝতে পারলে না বলো?
Sir, 4 থেকে না।
না আমি সেটা বলছি না। Target location. I am talking about target location. The movement will be this 3. This particular 3. This particular 3 will be not in this particular place. 3 will be here. Sorry, 3 was 22 will be here. So actually the target location, what are the target location? My target location is from 5 to 8, and the movement is starting from where? And the movement is starting from 7 to 4. So 7 to 4. So see, like this one, if it's not clear, that is, if I have written down like this, that 8 to 5, 7 to 4 means 8th place data will be going to 7, 7th place data will be going to 6, 5th place data will be going to 4th place data will be going to 4, and তিনটেই তো মুভ করছে, 7এরটা 8 এ আসছে, 6এরটা 7 এ যাচ্ছে, 5এরটা 6 এ যাচ্ছে, আরে ঠিক আছে লিখেছি। 7th place data is going to 8, 6th place data is going to 7, 4th place data is going to there, and আরে এইখানে মুভ করছে,
সে 6-5 হলো,
6-5 হবে, ওই জন্যই হিসেব লিখছে না, ঠিক আছে। 5th place data is going to 6, and 4th place data will be going to 5. Like this, the movement is occurring. So this 7th place data is coming to 8, 6th place data is coming to 7, 5th place data is coming to 6, and 4th place data is coming to 3rd. Yeah, we have started from 0, so just increment with 1. Okay, so these are the target location, these are the source location. So that's how it moves. Clear until up to this one?
Yes.
Clear up to this one?
Yes, sir.
Yes, sir.
Very good, very good. Now look one thing. Okay. So 8 is what? Number of the occupied places within the array. So 8 can be denoted as 8 is what? That is the number of occupied places before the insertion operation.
Array.len.
Right? So 8 can be denoted as n. Very good. N. And I am inserting the data at the 5th location. So I can write in place of 5, I can write the target location LOC from where the insertion operation is starting, because the shifting will start after that, right? So that's why LOC. Okay, same like the previous one. What we are doing in the time of string formulation, what was there? The movement was 7. Okay, so how to get 7? N is our 8. So how to get 7?
N-1.
So n minus 1. 4 location is 5. So how to get 4?
LOC minus 1.
Location minus 1. So this will be the term you are going to use, or this will be the formula you are going to use at the time of your programming. Now look here. If I is the target location, look at this point here. If I is the target location, means this particular position is the target location number for I equals to n, I less than equals to location. Okay, I has to be less than equals to the location number, because I is going to get insert on that particular location. I minus minus. Okay, now look at the scenario here. Means that particular thing which is moving there, I equals to n, means when I equals to 5, I is less than equals to location. Yes, I is less than equals to location. So I minus minus. So it will be going to get moved to the, it's moving from this to this location. While we are doing target location operation, see, we are doing target location operation, means this data is moving from source to target. Okay. So this is the formula for that one. So next will be AI equals to AI.
Greater than equal to. I greater than equal to location.
I greater than equals to location মানে আমি যখন পার্টিকুলারলি ওই লোকেশনে ঢুকে আমার তো তারপরে এগোনোর দরকার নেই না, আমার তো ওই জায়গাতে ডেটাটা কাজ হয়ে যাচ্ছে, ইনসার্ট হয়ে যাচ্ছে।
হ্যাঁ স্যার
7টা যখন 8 এ মুভ করে গেল, আমাকে তো আর 9 এর ক্যালকুলেশন দরকার নেই। আমি কি what we are doing, we are decrementing the thing from 7 to 8, so 6 to 7, so the data is getting decremented. প্রথমে 8 এ মুভ হয়েছিল, তারপরে 7 এ মুভ হলো, তারপরে 6 এ মুভ হলো, তারপরে 5 এ মুভ হলো, লাইক দ্যাট। বুঝতে পেরেছো? সেই জন্য I minus minus. If I am getting in, if I was increasing the data, I would have used I plus plus. ঠিক আছে? And AI equals to AI minus 1 means what? That if previously the array A was holding the data at 5th location, means after movement the data will be held at 5 minus 1. Got the logic?
হ্যাঁ স্যার
Okay, very good. Same thing in here. Previously we have used target location. Here we are using source location. If you want to program your code depending on the source location, then what will happen? That if I equals to n minus 1, okay, if I equals to n minus 1, so this is our first. Previously we are doing target location, now we are doing from source location. So obviously we are going to deal with the 7 to 4 location, this particular thing. This is for the source location calculation, and this is for the target location calculation. So obviously, like the previous one, just in places here we are going to switch. In place of n, we are going to write n minus 1, because this is the starting point. I less than equals to, previously it was only location, so location is here what? Location is 4 is our location minus 1, so LOC minus 1, I minus minus, it will again start decrementing, and AI plus 1 equals to AI, means the new target location is the is previous 5th location, or like this particular thing, just it's going vice versa. Means what? That if AI plus 1, here the value of I is what? Here right now the value of I is, let's say 4. Let's consider this one 4. So A4 is source location. Sorry, A4 is source location for which particular item? AI plus 1, or we can say this data has moved from which particular location? This data has moved from AI location or A4 location. So this is the logic behind it. So the data of A4 source location is coming to where? Coming to AI plus 1 target location. Okay, 4 is moving to 5, right? Same logic. One is for target location, another is for source location. So it's your total, depends on you that which particular form you are going to use. Okay.
yes sir
আচ্ছা সেটা বলো চমকে যাচ্ছে ওকে নাও we have did these two operations with a particular sample code okay you have to do some tweaking on this code and write it properly but this is the main code okay so algo array হ্যাঁ বলো
স্যার ওইখানে একটা বললেন না যে ডিক্রিমেন্ট হচ্ছে একদম মানে ফার্স্ট যখন টার্গেট লোকেশনের ওখানে ওটা ডিক্রিমেন্ট হচ্ছে মানে ওটা বুঝলাম না কারণ 7 থেকে
না
8
না
এ
না,
যাচ্ছে
প্রথম আমি কি বললাম শুরু যখন হচ্ছে আমাদের এক্সট্রিম রাইট থেকে শুরু হচ্ছে ঠিক তাহলে 8
হ্যাঁ।
থেকে আমি শুরু করলে 7 এ যাব মুভ করার সময় মুভ করার জন্য বলছি আমার লোকেশনটা কি হচ্ছে 7 থেকে 8 এ মুভ করে গেল ঠিক আছে তাহলে আমি যদি i প্লাস প্লাস করে দিতাম তাহলে আমাকে কি করতো 8 থেকে 9 এ মুভ করতো কিন্তু আমি ডেটাটা তো ওইরকম ভাবে মুভ করছি না এখানে দেখো কনসেপ্টটা কি চেঞ্জ হয়ে যাবে i প্লাস প্লাস করে দিলে আমার ডেটা মুভমেন্ট স্টার্ট হবে এইরকম হবে ঠিক আছে মানে 2 এর ডেটাটা 2 ধরো লোকেশন নাম্বার 1 এ আছে এখানে 4 আছে এখানে 6 আছে তাহলে আমি যদি i প্লাস প্লাস করে দিই তাহলে কি হবে ইনক্রিমেন্ট অপারেশনে চলে যাচ্ছে ইনক্রিমেন্ট অপারেশনে হলে কি হবে 2 টা গিয়ে দুম করে 4 এ সুপার ইম্পোজ হয়ে যাবে 4 কারণ ইনক্রিমেন্ট হচ্ছে না পজিশনটা আমি যদি ইনক্রিজ করে যাই 4 টা গিয়ে দুম করে 6 এ শিফট হয়ে যাবে কিন্তু না আমরা ডিক্রিজিং অর্ডারে যাচ্ছি দেখো আচ্ছা এখানে চলো 1 2 3 4 এই ডেটাটাই হোল্ড করছে আর এটাই হচ্ছে পজিশন যদি আমি ডিক্রিমেন্ট অর্ডারে কি হচ্ছে দেখো তাহলে 4 এখানে আমি দিয়ে দিলাম 5th তাহলে 4th পজিশনের ডেটা 5th এ চলে গেছে তাহলে আমাকে নেক্সট আমাকে মুভ করার জন্য আমাকে i প্লাস প্লাস করতে হবে না i মাইনাস মাইনাস করতে হবে
i মাইনাস মাইনাস
আমি ডিক্রিজ করছি তাহলে কি হচ্ছে থার্ড প্লেসটা আবার 4th এখানে শিফট হবে আবার আমি একবার ডিক্রিজ করব তাহলে সেকেন্ড প্লেসটা থার্ড প্লেসে রিপ্লেস হবে আবার আমি একবার ডিক্রিজ করব তাহলে 1 টা 2 এ ডিক্রিজ হবে বুঝতে পারলে কেন i মাইনাস মাইনাসটা করা হচ্ছে ঠিক আছে now look for the algorithm okay so algo array insert a malloc n location and item okay so a is our array max location malloc bolam sorry max location is number of the location the array can hold or size of that array that is our max location max number of location it has and max number of data it can hold n is the number of occupied place okay next is our location loc where we are going to insert the data and next is our item the data we are going to insert so here these are all character type but here see the value of n is we are going to work with the value of n so either the value of n is going to change so that's why if you are using c programming remember this one this n will be done with the help of call by reference ঠিক আছে এখানে আমি লিখে দিয়েছি যখন তোমরা জুম করবে দেখতে পাবে নোটে ওকে so we are performing n should be if you are using this particular code in c programming remember to use n এটা ওই ভুলভালটা না
হ্যাঁ স্যার
আচ্ছা রিজেক্ট করে
ঠিক আছে thanks so whenever if you are using c programming remember to use call by reference in case of n okay otherwise the program won't execute so here look at the program so if max location equals to n okay if max location equals to n print overflow okay what is the condition or what's the meaning of this particular line if max location equals to n means what was n n কি ছিল বলো n was
লেন্থটা টোটাল
না ভুল হচ্ছে that was max location I'm not talking about max location I'm talking about n what was the n here
array size
Sir, occupied length.
total occupied place yeah total occupied place so max location and the total occupied place is same means what there is no chance for inserting the data or the other data will be disrupted okay so that's why overflow condition print overflow and exit from there this is our use of overflow condition okay exit so clear about these two lines
স্যার প্রথমে ওটা চেক করে নিতে হবে
first yes exactly first we are checking that whether we can perform insert operation on that array or not okay so if we can perform insert operation okay very good it will come here but if we can't perform anything means all the places are occupied so simply it's going to show you that this is overflow condition and the program will exit from there ঠিক ठीक है तो?
Yes, sir.
Yes, sir.
Cheers. Next means if we are coming to this for loop means overflow condition hasn't appeared and there is empty space in there. So the condition is for I equals to n, I less than equals to location, I minus minus. Okay, same thing. This particular code we are using. See. Just write down this particular loop that if you are using target location here, if you want to change the code, you just put this particular code in here and the program will also execute smoothly. Okay, so it depends on you. Here we have used target location. So if I equals to n and I less than equals to location, I minus minus. So like that, the shifting operation is starting. So ai equals to ai minus 1. So the ai up to this, okay, up to this part, the total shift operation has been done. So ai equals to ai minus 1 means fifth place data is in fourth place data, sixth place data is in, fourth place data is in fifth place data, fifth place data is in sixth place data is in seventh place data is in 8. So the data movement has been done. Means this particular, for this program, this particular position, the fifth location has now become empty. So that's why we are checking this condition that whenever I is going to get reached at the position of that particular location, that I is becoming 5. When I will become 5 means that particular fifth location is empty. So I can easily insert my data there. So just insert the data here. So a location equals to item, b equals to n plus 1, etc. Why n equals to n plus 1? This particular line is being used to update the system or update the program that the number of occupancy or the number of occupied places within the array has increased by 1. Because in the next program, or let's say in the next iteration, you might want to insert again. So the calculation of the empty spaces is also necessary. So that's why this last line is also necessary, that n equals to n plus 1, the number of occupied places. Since here we have done one insert operation, the number of occupied places got increased. Okay? Yes. Great. So now we are coming to array delete operation. Okay. So what we are doing, like the same thing. First, we are going to check whether there is any kind of data to be deleted or not. Means if there is any kind of data or not. If there is no data, means the array is empty, then that will be underflow condition. Means we can't delete anything. Okay, we can't deduct anything from 0. We can basically mathematically, but basically we can't do anything. So we have to remember this one, that like the previous one, here we were at the time of inserting, we are checking for overflow condition. So at this time we are going to check for underflow condition. Okay, so like this, first, whenever you are getting any kind of program or whenever you are doing you are getting any kind of questions regarding interview or any like thing, or wherever you are doing practice in your home, just before doing any kind of program, just put it in a mathematical form and it becomes much more easier. So see, here array is our A. So array is, this is A. This particular A is holding this particular array, but this is the name of the array. So this one is important. So write down A is our array. The number of max location is ranging from 0 to 11, so it will be 12. So max location is 12. The total occupied place means n is our 0 to 7 means 8. We are deleting the data from location number 4. So this particular position, this item 17 will be deleted. So that's why location 4, and still we haven't got in the item. So that's why we have put the question mark here, because we, before the deletion operation or before the extraction, we don't know what is the item that's being moved at the fourth position. Okay. So see, at the time of deletion operation, so 17 got deleted, right? If 17 is getting deleted, so at the time of insertion operation, we are moving from 7 to 8, 6 to 7, like that. Okay, but at the time of insertion operation, deletion operation, a particular empty space will be created within the array. It might be on the starting, it might be on the end. If it's on the end, so there is no need for shifting. But if it's in from starting to before the end, okay, so if it's starting from 0 to, let's say, n minus 2 position, so obviously we have to shift. So means within a particular, within among this particular location, a empty space is there. So the movement will start from the opposite direction. Previously, the movement was like this. Here, the movement is like this one. Means 17 will be removed. So 22 place data will be coming to, sorry, fourth place data, fifth place data will be coming to fourth place. Sixth place data will be coming to fifth place. Seventh place data will be coming to sixth place. Eighth place data will be coming to seventh place. And this particular location will become empty. Got the concept? How the movement is going?
Yes, sir.
Okay. So like that, same thing. So that is our target location. So 4 will be coming to 3. So that's why 3. And maximum is 7 will be coming to 6. So 3 to 6. This is the target location movement. And the location movement is starting from 4 to 3. Excuse me. 4 to 3. And the maximum location is moving starting from 7 to 6. Okay, so 7 is, and here 7 is the highest one and 4th is the lowest one. So that's why 4 to 7. So like the previous insertion operation, again we are going to find out the formula in order to reach 3. How we can reach 3? Location is our 4. So we can easily write in place of 3, LOC minus 1, that will be our 3, right? How to get 6? So what is our total occupancy? 8. So n minus 2. 8 minus 2 in place of 6 we can write. So that will be the maximum and minimum of target location. If we come to source location, 4 is what? 4 is simple location. So in place of 4 we can write LOC. And 7 is the highest source location. So how to get 7? 8 minus 1. So we can simply write n minus 1. So this is the simple formulation has been done. So now we are going to put it in the formulation. Now look. For I equals to, okay, for I equals to, we are working for the target location. For I equals to LOC minus 1, I less than equals to n minus 2. N minus 2 is 6. That is the highest movement point. After that, there will be no movement because after moving the 7 data to 6, there is no need for any kind of movement there because rest of the part is empty, right? Rest of the part is empty or not?
Yes, sir.
Okay, so that's why this is the limit. So I less than equals to n minus 2 means when I will reach to 6, the movement has been done, the total movement has been completed. কেউ কিছু বলেছিল? No. ঠিক আছে. And see, the movement is here on the opposite direction. So that's why I plus plus. If the movement was like this one, then it should have been I minus minus because we are decreasing there. But here we are increasing one by one. So that's why it's in I plus plus. Okay. Did you get the logic? Why here it was, why it was I minus minus and why this one is I plus plus? Is it clear?
Yes, sir.
Very good. So again, see here. So AI equals to AI plus 1 means what? This particular location's data. Okay. So AI equals to AI plus 1. So A4 will be holding the data of which one? A4 will be holding the data of A4 plus 1, or we can simply say A5. So when 4 to 3 has been A5, so when 4 to 3 has been moved, so means this fourth place is become empty. So the next movement will, sorry, fifth place has become empty. So the next movement is going to start. So obviously we have to increase the position number by 1. So A5 movement will start. So A5 will be holding which particular location data? A5 will be holding the data for A5 plus 1. And like this, we are going to go for up to n minus 2. N is what? 8 minus 2 is what? 6. So A6 will be holding the data for A6 plus 1, and after reaching A6 plus 1, okay, after reaching A6, obviously it will again get increased and the value of I will become 7, but there is no need for any kind of movement there, for the rest of the place is empty, so that particular thing will get exhausted and it will exit. Okay, that is the logic behind this one. So we have done with the target location, means this condition, and now sorry, this condition. So now we are work with the help of the source location. So if I is the source range, okay, how we can write? If I equals to location, okay, if we are moving that thing on that particular location, এখানে আমি একটা I miss করেছি, sorry, I less than equals to n minus 1. So up to until which position this thing is going to happen? This is going to occur till n minus 1. In 7th positions data is going to get, means here it will be on the different side, that A7 data is going to get moved to, sorry, A6, okay, so that is the logic behind it, and again after that it will get incremented I plus plus. So this is the logic for the source range. Okay, so now we are putting this one in a program code. So algo array delete, A is the name of the array, max location, the array can hold, m number of occupied place within that array, item, that particular item which we are going to insert, and location, on the particular location, sorry, item, that particular item which is going to get deleted, and location, that particular position from where the item is going to get deleted. So first checking for the underflow condition, if n equals 0, means if the number of occupied places is 0, then print underflow, there is nothing to do, and exit from there. And if underflow condition is not occurring, means some kind of data is in there, so item equals to lup, means bring out that particular item. So I, then this position in here, in 4th position was holding the data 17. Okay, so we don't know either that particular data might be again used or not. We are just moving from there right now. Delete operation is moving a particular data from there. So that's why we are keeping this particular data 17 in here. Okay, so this particular location, from this particular location, a location means item is going to get deleted, extracted from position 4, and then we are going to just perform the, when the deletion operation is done, means what, this particular place, this 4th place has become empty. So now we can easily start our shift processing. So the shift processing code had been written here. So again it getting shifted, and after shifting of all the data within that array, we are going to update n equals to n minus 1 to let the program know that how many occupied places are there. So if only one data was there, so it will update itself 1 minus 1 0. So next time whenever the program is going to get executed, it will just can easily exit from there underflow if we want to perform any delete operation or not. And if it's the value of here, like here, it will become update here as 7. Obviously again no underflow condition will be there, and if we are deleting any kind of data, the data will be deleted from there. Okay, clear about the insert and deletion operation? Is it clear about the insert and deletion operation? সেটাই follow. I will let you do it. Now next is our memory representation of one dimensional array. A array, basically a array, how it gets represented within our memory space. Okay, so here we have taken this particular array which has 10 locations. So 0 to 9, 10 locations are there. Okay, we have named this particular thing as LA, linear array. Okay, we have decided no, that this thing has been given the base address, means the starting address of the, obviously a array is holding a data, each and every of them is going to have a base address. So here we are saying that the base address is starting from 2000. That's why base address is 2000. Okay, and here it has been defined that each of this location, the size of each of this location is 4 bit. Okay, it has been mentioned. So that's why width of this each of these location is 4. W equals to 4 we have written. Okay. Now we are checking for upper bound and lower bound. Okay, and before that we are writing down the k is equals to 3. We are going to come to this thing later. Location of LAK. How to find out that location LA, this particular k is 3. That if we want to find out that location linear array 3, what is the base address for this one? So how the computer is going to find out? It will come to this place. So if it will come to this 3 location, and in 3 location it's saying that the starting base address is 2012. So it will update itself as 2012. That this is the base address for this location A3. So this is our K, this is our location LA. Okay, upper bound and lower bound. We are coming to that later. Look. So here, look, each of these are holding 4 bit. So it's starting from 2002 to 2003. So 2000, 2001, 2 and 3. 4 places. Here again 4 places, 4 places. So up to until 2039. Because 10 locations are there. So each of the places have 4 bits. So total with the help so since there is only 10 places here, so the total size will be 40 bits. Right, and here we are starting from 00, so obviously it's going to end at 2039. Okay, now how to find out? We have found out this one as 2012. So how we basically find out that which particular, if we are calculating that this particular array has this location. So from this location, what will be the starting base address? So the formula for this one is location LAK. Okay, location linear array, the name of that particular array. K is the kth position data, which your kth position from where you want to check the base address. So how you are going to find it out? The formula is base plus K, means the location you want to find out. Lower bound, here the lower bound is what? Here the lower bound is 0. Okay, and the upper bound is L, upper bound is 9. Okay, so K, the position from where you want to check, minus lower bound into width. Okay, so now look at this formula. Why this formula is, why this type of formula got generated? See, there is no concept or anything to explain this one. Why base is 2000? Because the starting address is 2000. Okay, yes or no?
Yes, sir. Sir,
Yes,
W
sir.
টা আগে বলুন স্যার।
কি বলছো বলো?
স্যার W টা স্যার বলুন একবার।
W টা হচ্ছে width, এইটা হচ্ছে তুমি ধরো একটা লিনিয়ার অ্যারে, তো এইটার তো একটা সাইজ আছে, 1 বিট, 2 বিট, 4 বিট, 8 বিট, 16 বিট, কিছু তো একটা সাইজ আছে। আমি এখানে 4 বিট ধরেছি, ঠিক আছে? আগের জন্য W টা। ওকে,
হ্যাঁ স্যার, বুঝতে পারছি।
ঠিক আছে। So see, we are checking the base address for this one. So in order to reach here, how many places we have to move? We have to move 1, 2, 3. We have to cover up these 3 places, right? In order to reach here. So that's why 2000 is the base address or the starting address. So we have written down the starting address. So how many places we are covering up? 3 places. So plus we are coming to on this 3 place. So if we perform 3 minus 0 into star 4, means the width of each of those blocks. So that will become 2000 plus 2000 plus 12. So it will come as 2012. Mean in order to reach here, how many locations you have to cross? You have to cross 2012 location, or it will be much more clear if we use 1 in place of 0. Okay. Now look here, this is 1, 2, 3, 4, 5. Here we are saying the base address is 100. And each of them, like the previous one, we are saying that each of them, not the previous one, here we are saying the width is 8 bit for each of this location. So 100 to 107, right?
Yes, sir.
108 to 115, 116 to 123, 124 to 131 and 132 to 139. Okay, so now we want to find out the base address of 5. Okay, we want to find out the base address of 5. So in order to reach here 132, if we use simple calculation, okay, what we are doing, we are calculating 8 locations here, plus 8 locations here, plus 8 locations here, and plus 8 locations here. So how many locations we have covered? 1, 2, 3, 4. So 4 into 8. So in order to reach here, how many locations we have to cover up? In order to, because whenever the computer or the program is going to do, it's going to start from the beginning. So 1, 2, 3, 4 like that. So what will be the, in order to reach here, how many places we have covered? 32 places. And what is the base address here? 100. So in order to reach here, we have covered up 32 places. So what will be the base address for the 5th place? 132, right? Simple calculation.
Yes, sir.
Now we are doing this thing with the help of the formula. So the formula was base plus location minus lower bound into width of the each particular block. So base is what?
100.
Which particular location we are finding the data for?
5.
5.
Minus 1 into 8.
Lower bound is 1. So 5 minus 1 into 8. Here we have taken the width as 4. See, the same thing. Now the concept is clear about this one?
Yes.
Okay, very easy. Okay, very good. So now let's go for the next one. Now look here. Previously we have done one-dimensional array. Okay, means each of the location was holding a particular single data, linear array. But here we are doing this thing with memory representation of two-dimensional array. Okay, here we are using two-dimensional array. Sorry, my bad. And this particular thing is called row measure. Okay, so whenever we are doing two-dimensional memory representation, there are two types. One is our row measure, another one is our column measure. Row measure means we are giving the highest priority to row. How? That this particular, look at this one here. First look at this particular data. The data distribution is each of this particular location, like the previous one, is holding 4 bits of data. So that's why W equals to 4. Here the starting base address is again 2000. So base equals to 2000. Okay. So here if we check, so it has obviously row and column. So if we are checking here, what is the lowest bound for the row? What is the lowest bound for the row? Lowest bound for the row?
0.
Huh? Lower bound bolchi, upper bound bolchi. What is the lower bound for the row? Lower bound to কি আছে এখানে রোতে সবচেয়ে লো কি রোটা সবচেয়ে লোয়েস্ট রো কি মার্ক করা আছে
0.
0. So RLB will be 0 and upper bound will be
2.
And same thing if we want to find out for the column, which is the lower bound for the column?
0.
And upper bound will be
3.
3. এটা আমি L লিখে দিয়েছি, U correct করে নেবেন, ঠিক আছে? So column upper bound will be 3. So this is the row representation. Okay. Now here we are using 2-dimensional, means each of them are going to get considered by the cross dimension, means x and y axis, means 0,0 is holding the data of 2000 to 2003. 0,1 is holding data for 2004 to 2007. Here we are finding out that location A, this is our array. Okay, so the name of the array is capital A. So location A 1,2. Okay, 1,2. So one row, 1th row and 2th column. So 1th row we have come here and 2th column means this particular position. So we have to find out the base address of this particular thing. So how we are going to find out? Look at the formula. So the formula is location array name row comma column base plus width of the each of these locations. Now getting multiplied with within bracket row minus row lower bound. Okay, so number here I have written number of rows that was crossed. Okay, আমি ফর্মুলাটা যখন দেখাবো তখন বলে দেবো, ঠিক আছে? Into column upper bound minus column lower bound plus 1 plus column minus column lower bound. Why? এবার দেখো ক্যালকুলেশনটা করছি। So in order to reach this particular location, in order to reach this 1,2 location, how many rows I have to cover up? Yes, sir. How many rows we have to cover up? In order to come here, how many rows we have to cover up? We have to cover up one row. So 1, 2,
Only one
3,
row.
4. ঠিক আছে? After crossing this 4 row, we have reached on the first row. Okay. In the first row, how many column we have to enter inside there? We have to cross again 2 positions, 1, 2, then we will be able to reach here. So same calculation like the previous one. We are coming like this. So 1, 2, 3, 4, 5, 6. At this 7th location, our base address will be holding. That's why the base is 2000. Width is 4. Very good. Row minus row lower bound. Which particular row we are checking for? 1,2. So 1 minus row lower bound. Lower bound is 0. So 1 minus 0. That number of row we are crossing. That's why 1 row we have crossed. So 1 we have got there. Again, in order to reach here, how many column we have to cover up? So column upper bound minus column lower bound. So column upper bound is what? 3 and column lower bound is what? 0. So in order to reach here, so 1, 2, 3, 4, we have covered up 4 columns in there. So that's why 3 minus 0 plus 1. Okay, plus after reaching in this position, after completing this, we have reached to the target row. And now after reaching the target row, we have to insert again how many places in order to get here? In order to reach here, how many places we have to enter within the matrix? কতটা place ঢুকতে হচ্ছে বলো?
2 columns.
দুটো, so 1 and 2, so that's why here the formula is C minus column lower bound, means C is our column number, that is our 2, so 2 minus column lower bound, 2 minus 0, so that many positions you are going to get inside there. If we are looking for 1,3, so obviously it will be 3 minus 0, means you have to add, in order to reach here 3, you have to cross 1, 2 and 3 position in order to reach here. If you are looking for position number 2,3, so in order to come here 2,3, first you have to cover up these two places, these two rows and these 4 columns. So obviously this will be turned as what? This will be 2 minus 0 in order to reach here. First you are going to perform 2 minus 0. Again, in order to come here, how many columns you are covering up? You are covering up 4 columns, so 3 minus 0, it will be here. And then in order to reach here, how many places you have to enter inside that particular matrix? 3 places if you are finding out for 2,3. Okay, so then 3 minus 0, this is the formula, and you are going to easily get the result 2024. And if you are using simple calculation, then what? 4 plus 4 8 plus 4 12 plus 4 16 plus 4 20 plus 4 24. So we have crossed 24 positions. So it will be basically simply 2000 was the base address, so 2000 plus 24. But at the time of programming or doing the calculation, we need the formula. So with the help of this formula, we can easily achieve this. So is it clear how memory representation is getting placed here?
Yes, sir.
Okay.
Yes,
Now
sir.
why
Yes.
this? Achha. Now look at this one. So this particular term, row measure. Why this one is called row measure? Means whenever the data is moving here, the first data of the row will enter in the first data of the column, and the last data in the row will enter as the last data of the column. Okay, this particular row will enter here, and this will enter here. So here is the lowest row will be at the bottom of the column, the highest row will be at the top of the column, the first data of the row will be at the starting of the column, the last data of the row will be at the bottom of the column. Okay, so here the priority of row is very much higher. That's why this one is called row major or column minor. Okay, remember this one. So in competitive exam, you might get question like that. Then if this type of thing is happening, so whether it's a column minor, column major, row minor, row major. Okay, at that time you have to choose both those two options, that row major and column minor, because both of them are same. Okay, so row major or CM, column minor.
স্যার এটা একবার রিপিট করে
কোনটা বলো?
স্যার রো মেজার আর কলাম মাইনরটা কেন হচ্ছে?
রো মেজার আর কলাম মাইনার কেন হচ্ছে না? রো মেজার কলাম মাইনার দুটো একই জিনিস। This is the same thing. Row major is also called column minor. Okay, আর কিছু না, রোটাকে এখানে মেজরিটি দেওয়া হচ্ছে, তার মানে মাইনরিটিতে কে আছে? একটা ম্যাট্রিক্সে কি থাকে? রো আর কলাম থাকে। রো কে যদি মেজরিটি দেওয়া হয়, মাইনরিটি কার কাছে থাকবে? কলামের কাছে থাকবে। সো রো মেজর, কলাম মাইনর। ওকে, কেন রো মেজর বলা হচ্ছে? বিকজ রো হ্যাজ দ্য হাইয়েস্ট প্রায়োরিটি। এটা আরো বেসিক্যালি ক্লিয়ার হয়ে যাবে যখন আমরা এখানে কলাম মেজরটাকে আমি বলে দেবো, তখন তারপরে বুঝতে না পারলে বলো, আমি আরেকবার বলে দেবো। ঠিক আছে, এটা column major. So previously see here row has the highest priority, means the distribution. Look at the distribution 2000 to 2003 4, then the next data is getting inside the second row, third row, fourth row. Clear? In row major the data is getting inserted row by row, first row, second row, third row, fourth row, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th. Yes or no? একই না বলো?
Yes, sir.
Okay, in column measure, see what is happening. The data is getting inserted column wise. So first, second data, third data, fourth data, fifth data, sixth data, 7th data, 8th data, 9th data, 10th data, 11th data, 12th data. Is it clear how the data distribution is in column measure?
Yes, sir.
Okay, so here look, here this was the representation for row measure, means first data of row is getting inserted here and first data, last data of row for this top row is getting at the bottom. Here in case of column measure, look, so obviously in column measure the data is distributed in column structure. Here the data got distributed is in row structure, and here the data is getting distributed in column structure. So one plus point for column measure and row measure, why this one is called row measure and why this one is called column measure. Second thing, here the first data of the column will be on the top of the column and the last data of the column will be at the bottom of the column. And again like this, so on and so forth, it will work on. So now did you get the concept that why this one is got row measure and why this one is got column measure? Because here the distribution of data is according to row. The marking is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whenever the insertion is occurring or the deletion operation involved in row measure, the data is going to move like that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But in column measure, what is happening? The data is distributed in column wise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So according to that, whenever we are doing any kind of operation, the data will move. Ever thought clearly to row measure, column measure, and column measure is also called row minor because row has the lowest priority here. KGS ko chile to clear holo column measure, row
Yes,
measure.
sir. Yes, sir.
Okay. Very good. Now look here. Same thing. We are going to check for the formulation here. Okay. So what is the base size here? Base is 2000, like the previous one. Very good. The width is also 4. Previous one. Very good. Now the column upper bound is what? Column upper bound is 0, and column lower bound. Column lower bound is 0, and column upper bound is 3. So 0 and 3. Row upper bound is 2, and row lower bound is 0. So lower bound is 0. Upper bound is 2. So we have got all this from the matrix. So now we are going to find out location A1, 2. Okay, so location A array 1, 2. So 1, 2. So we are going to find out the base address for this particular location. Again, like the previous one, in order to reach here, how many places we have to move? See, the only difference here. Here we are also looking for 1, 2 data, but here in order to come here we are moving like this 1, 2, 3, 4, 5, 6, 7. But here in order to reach here we have to move like 1, 2, 3, 4, 5, 6, 7, and this is our 8th place. But here it was on the 7th place. So saw the difference between row and column measure? Okay, so now look at the formula. So location array R, C, row name, row number and column number. So row number is 1, column number is 2. So 1, 2 we have written here. Okay, very good. This one is good. Next, formula is stating that base address, we have to write it down. So base address is here is 2000. Very good. Is getting added with the width. Width is what? Width is 4. So W is 4. Now, in order to reach here, how many columns we have moved? 1 and 2 column, right? In order to reach here, we are moving how many columns? 1 column and 2 column? Yes or no?
Yes, sir.
Okay, so that's why this formula C minus column lower bound. In order to reach this particular location, how many columns we have crossed? So that is 2 minus 0, because we are finding out the data for 1, 2. So we have got 2 minus 0. Again, after reaching here, how many row we have to? How many row we have to enter inside in order to reach here? Then we are going to write down this one. So row upper bound minus row lower bound plus 1. In here it was column upper bound plus column lower bound, because in order to reach here, how many columns we have crossed? Okay, here all the things will just change. These rows will become column, the columns will become row. Okay, otherwise this is the same formula. Okay, the only difference is here we were moving side by side, and here we are moving from top-down approach. Okay, that is the difference between row and column measure. So see, the movement here will be, in order to reach here, how many rows we have moved? We have moved 3 rows. Okay. In order to, this is our third row. So 2 minus 0 plus 1 plus row minus row lower bound. This is our 1. And in order to reach here, how many row we are crossing? Only one row we will be crossing here in order to reach here. So that's why 1 minus 0. And after doing the calculation, we are getting 2028. Again, 6. 4 plus 4, 8. 8 plus 4, 12. 12 plus 4, 16. 16 plus 4, 20. 20 plus 4, 24. 24 plus 4, 28. So obviously 2000 is my starting address. The base address will start from 2028. And if we are using this formula, we are going to get it like this. Clear? Is it clear or not?
Yes, sir. Yes, sir.
Yes, sir.
Okay, very good, very good, very good. Now, next is our saddle point. So I guess you guys know what is saddle point, right? Do you know what is saddle point or not? अरे जानो कि जानना सेटा तो बोलो
Sir, একবার বলে দিন স্যার।
अच्छा
Sir,
बोलो
बोलो।
ठीक है बोलो okay no problem no issues there. So the definition of saddle point is whenever a matrix form is getting represented, that particular number either have to be highest in row and lowest in column, or it can be lowest in row, highest in column. For instance, look at a particular example here. See 15, 7, 20, 10. In this row, which particular number is the highest? In this row, 20.
20,
And if we look at this particular column, which particular number is the lowest number?
30, 20.
20. So this one is called saddle point. Why? Because it might be highest on the row and lowest in the column, or highest in the column and lowest in the row. But here we have one condition got satisfied, that is row highest, column low. Okay. Next, if we are looking for another number, let's say this one. See, 11 is highest within the row and lowest within, highest within this column and lowest within this row. বুঝতে পারলেন কেন স্যাডল পয়েন্ট চুজ হলো এটা?
Yes, sir.
Okay, and remember one thing, that but it can be a matrix which is holding data 1 1 1 1 1 1 1 1. Okay, if in matrix you are seeing that they are holding same kind of data, then all the points in that particular matrix will be saddle point. Okay, বুঝতে পারলে কি বললাম?
Yes.
If you are having a matrix and each of the data within that matrix are same, means they are neither bigger nor smaller, means they are all equal, then all and each every point in that particular matrix will be a saddle point. Okay. So again, look at this matrix. So for matrix representation, and whenever we are doing anything on the matrix, first we have to find out the upper bound and lower bound of row and column. Okay. So if we look here, the lower bound for the row is what? 0, and the upper bound for the row is what? 2. So we have written now the lower bound for the column is what? 0. The upper bound for column is what? 3. We have written 0 and 3. Okay. So now look at this formula. Look at this program code. So here the concept of flag is very much important. Why? Because with the help of flag, we can just change the whole program code. Okay, look here. Here we have stated, first we have stated that flag equals to 1. Okay, now we are checking that for k equals to 1. When we are checking for the first data, k equals to 1, k less than equals to 2, k plus plus. Okay, but before coming here, just look at this particular matrix. So a particular, whenever we are dealing with saddle point, we can do one thing in order to ease this particular one, but that we can choose the maximum of each of the row, or you can choose maximum of each of the column, depends on your programming. Okay, But if you choose like that, it becomes much more easier to calculate. How? See, for this particular example here, see, which one is the highest here? 20 is highest here in this row. So we have taken this matrix and written down 20. Among this, which one is the highest? 34 is the highest. We have written down 34. And here, which one is the highest? 65. 65 is highest. So now, if we simply compare each of the number, okay, if we have compared each of the number with this particular point of this particular row, so 15 is getting compared with 20, 15 is lower. Okay, no issue. 7 is getting compared with 20, 7 is lower. Okay, no issues. 20 is getting compared with 20, means 20 is the highest number within here. Means, okay, stop there and let's check for the column. And now we are checking that whether this one is the lowest in the column or not. So let's check 30. Okay, not possible. No, 30 means 30 is higher. 25, 25 is also high. Means this particular is a particular point. Which one is highest in the row and lowest in the column. Next, we are again come here. That is 34. Okay, now we are comparing with 34. 34, 21 is getting compared with 34. So 21 is obviously the lowest one. Okay, obviously lowest, so no issues there. 11 is getting compared, lowest, no need to check. 30 is getting low, 30 is getting compared, lowest, no need to check. 34 is 34. Whenever we are checking for I say column with the matrix comparison, just remember when we are getting the same kind of data at that particular point, this one is going to get checked. Otherwise, rest of the time it's not going to check there. That's how the time complexity is getting decreased. So after coming to 34, okay, after coming to 34, because 34 and 34 is basically same. So coming here, then there it will start that yes, this one is the highest. So now we have to check whether this one is lowest or not. And it's going to get compared. 34, okay, 34 is bigger than 10. First comparison and we found out that it is bigger than 10. No need to check this row again. It got exhausted from there. Again, it will come to this one. Now 64 is getting compared. 42 is lower. Okay, 8 is lower. 25 is lower. 65 is equals to 65. Means this particular position we have to check. So here again we are checking and finding out 10 is already lower than 65. Okay, 65 is already highest in the row. And again we are finding out that 10 is lower than 65. So obviously this point can be a saddle point. Okay, and this particular thing, all the rows got easily checked. Now for the column, if we find out the same like this one, if we formulate this one, so see, so 15, 21, 42, which one is highest? 42. 20, 30, 25, which one is highest? 30. Sorry, much kind of misspelling. Okay, 1, 7, 11, 8, which one is highest? 11. Here, the highest one is 30. And here, the highest one is again 65. So again, the comparison will start. So it's checking that 42 is 0 is lower, 15 is lower, 21 is lower, 42 is lower. So 42 is 42. Okay, whenever it's encountering the same number, then it's going to start checking that 42 is whether the lowest in that particular form or not. And it's finding out on the next iteration that 8 is basically smaller than 42. So there is no need for check and the program will exit from there. Now, next it's coming to 11. So 1 is smaller, 7 is smaller, 11 equals to 11. Means this one has reached to the highest column. Then it's going to check for the row that whether this one is the lowest one or not. 21 is lower, higher than 11, 30 is higher than 11, 34 is higher than 11. So this one will be marked. Okay, so this particular two row got compared. Next 30. So it will start from here. So 20 is lower than 30. 30 we have reached 30. So at the time when we have reached 30, it will compare with the rest of the numbers with the row. So 21 is lower and 30 is also already the highest. So it can be highest and highest on the both sides. So 30 will get deducted from there, exhausted, and it will come to the next one, 65. 65 again will get compared. So 65 will check. 10 is lower, 34 is 65 means this one is already the highest in the column. Now it will check for the column, and it's going to start from 42. Okay, and it will see that 42 is already lower than. So there is no need for check. So instead of checking each and every position one by one and comparing each and every number with each and another, with the help of only 4 and 3, 7. For this 4 into 3 cross matrix, okay, with the help of only 7 comparison, we can find out all the saddle point in that matrix. Clear? Why this MM, or we can say CM, maximum. Okay. We are using this particular 2 matrix in order to compare.
Yes, sir.
Okay, so now we are going to do this with the help of a formula. So see, flag equals to 1, okay, k equals to 1, right here, k less than equals to 2, and k plus plus, then it will go incremented. First it will go into check, then it will go on increasing. M value, if we have encountered the maximum value, which one is here? This one is 20. M value will be stored here. Okay, the maximum value is getting stored here. Now we are checking for I equals to 1, I less than n, I plus plus. Okay, and now we are checking that flag maximum value, whether this one is flag AI. Flag AI is holding what? Flag AI is holding this particular data. Flag AI is holding this particular data. This particular data is holding what? This particular data is holding 20. So now it's getting compared. Okay, and now it's checking that which particular number is lowered or not. So if all the numbers are here are basically higher than this one, so 30 is basically higher, 25 is also higher, means that is the particular number which can be termed as a saddle point. So that's how we calculated our max value. Okay, next we are changing this particular flag equals to minus flag. Now with the help, first we have checked the maximum value. Okay, so we have got 15, 7, 20 and 10. Among this, 20 is the highest number. Clear up to this one? Clear until this one?
Yes, sir.
Okay. Now we are checking for the, so we have already calculated the max value. See, with the same program, we can check the minimum value. How we are checking the minimum value? We are just converting the flag equals to minus flag. Means this one become what? In negative position. How? Look at this one. So 10 is lower than 20. It's okay, right? Sorry, there is no issues there. Okay, এটা বুঝতে পারছো তো? 10 is lower than 20. ঠিক আছে?
Yes, sir.
I am converting the flag to minus flag, means putting data, minus data in front of them. So minus 10, এটা just change হয়ে গেল, ভ্যালুটা ওখানেই থাকবে, minus 10, minus 20. Now which one is the higher? Now which one is the higher value?
minus 10.
Minus 10.
So obviously
Minus 10.
this will be switching. So see, when it was in plus form, when the flag was positive, it was calculating the value of max. And now after converting the flag to minus, this particular thing, this print value is going to print you the minimum value. Because whenever we are comparing this one, now all the values are in, we have got the maximum value. Now at the time of checking the value, we're just putting this one in negative form. So what will happen? It's going to check for the minimum value. And if this one is the minimum value, so it's going to check 25, 30, 20. So obviously with the help of this one, it can basically calculate minus 25, minus 30, minus 20. So which one? Minus 20. So minus 20. So 20 will be the saddle point. And it can easily find out your maximum value and minimum value. See the concept of flag? Do one programming in your home with the help of this flag concept, and it will be much more clear. Okay, so now we are coming to the main code. Okay, now look at this main code. Initializing the array. Okay, first we have to initialize the array A. Row lower bound, we needed. Row upper bound, we also need that in order to compare it. Column lower bound, column upper bound. Now look here. First, we are just putting this code here. So flag equals to 1, k equals to 1, k less than 2, k plus plus equals to a0. Okay, and for row we are also calculating. Okay, this one was for only column, and again for row we are also calculating. For r equals to 0, r less than equals to row lower bound, r plus plus. Okay, and here check for c equals to 1. Okay, when column is 1, c equals to 1, c is less than equals to column upper bound. Okay, and the column, it hasn't reached to the column upper bound, we are going to increment this one. Okay, And if flag BMMR means this particular value, okay, is lesser than the flag A comma RC, that which particular one we are going to get choose is basically lesser than this one, then that particular one is our desired one. Means for this one MM20 AR comma C means it will point out that 0 comma 2, so the data will be updated here. Okay, so 0 comma 2, you have got this one. Okay, so this one is our one loop. Okay, and now for this particular statement where we were checking this one, so for flag we have written down only these two parts. Okay, for flag equals to 1, k equals to 1, k less than equals to 2, k plus plus. Now rest of the part will start from here. So value equals to A, 0 comma C, row equals to 1, row upper bound. Okay, we are checking for row upper bound, row plus plus, it will keep on increasing until it has reached the highest upper bound or highest row upper bound. So it's going to go work with this one. Again, it's going to check whether, so see, here we were checking that whether AR comma C is greater than this particular value. Here we are checking that whether it is lowest in the row or not. So see, here it checked whether it's highest in the column, and here we are checking whether it's lowest in the column. So see, here it was in like this, and here this one. So like that we can easily find out. So first we are checking that whether this one is the highest number or not. Okay, if this one is the highest number, so 20 got selected. Next it is going to check that whether in that particular row lower bound, that up until row upper bound, that whether this one is the lowest one or not. And if this one is condition is getting satisfied, then value A equals to RC, means this particular MMR is the actual saddle point value. And for R equals to 0, R equals to row upper bound, row plus plus. That until then it's going to get compared. Now come to this one. If C, after that we are just writing down this one. So if value equals to A R comma C, okay, the value we have got in that particular row column is value equals to MMR, means we have found out that 20 is getting satisfied, and that particular value in MM is also same. If those two values are same, then that declare that particular thing as saddle point. Okay, after doing the comparison, if we are finding out that this value and this value are basically same, then we can simply declare this one is as a saddle point. So this one is for MM. Okay, when we are checking for the like this. And now if we are checking for like this one, for this particular thing, okay, here we have chosen the highest one. Here we can choose the lowest one also, or the highest one. So what we have to do, just we have to convert the flag equals to minus flag. So previously it was calculating the maximum value, and now after this one, doing this one, it's going to start calculating the minimum value. Okay, and now your program will easily going to find out that which are the particular saddle points. So with the help of this particular max value thing, first it's going to find out that 20 is the saddle point, and in the next iteration when you are going to put the flag equals to flag minus 1, it's going to start comparing, and for this particular example it's going to find out that 11 is the answer. So in the first iteration you are going to get the answer 20, and in the second iteration you are going to get the answer 11. Because first it's going to get calculating with the maximum value, and in the next point it's going to calculate with the highest minimum value. Okay, so in here if you look here, so see 15, okay, 15 is the lowest one. This is the minimum value going to get calculated. The minimum value here going to calculate is 7. The minimum value here is going to get calculated 20, and minimum value here is going to get calculated as 10. So if you have missed any point, it's going to basically find out here. So 15 is the minimum. So is 15 in the highest in that row? No. Then no issues there. 7 is the minimum. Is 7 is the highest in that row? No. 7 got rejected. 20 is the minimum. 20 is the 20 is the minimum. 20 is the maximum in there. So obviously 20 again MM got spotted, and MM will be selected. Again coming here. 10, 34, 65. Again, if we come here, we are finding out that 10 is the lowest, but 10 is not the highest in that particular row. So obviously 10 will be get rejected. So from there, like that easily, the computer will point out that these two are the saddle points in that particular matrix. Rest of them are not the saddle point. So write this code in your home. You have already the code. Just put some tweaking in there, means the standard library function and all those things, and this one will execute. Okay, do this one in your home. I barbar bolchi এটা practice করে একটু বাড়িতে হ্যাঁ
ওকে স্যার
okay this will do these two things. Okay, not two things, these three programming. First, array insertion. আচ্ছা দাঁড়াও এটা কেটে দিই এক মিনিট। Okay, do three programs. Okay, these are your homeworks. First, array insertion, array deletion, and then saddle point formation. You have heard about this one. Program ta dekhbe na. Program, don't look at the program. Do it on your own. If it's not getting solved, then ask a friend. Still, don't look at the program. And if your friend is not even able to understand you or not able to solve this one, then you might go for program. Okay, or you might ask me before going to the program. ঠিক আছে, প্রোগ্রামটা যাওয়ার আগে দরকার আমাকে একবার জিজ্ঞেস করতে হবে, প্রোগ্রামটা প্রথমে আগে দেখে নেবেন। ওকে, যে অ্যাকচুয়াল প্রপার যে প্রোগ্রামটা আছে, কারণ তুমি if you are going to search in the internet, you can easily get the codes for this one. But some of you are going to program in C and some of you are going to program in Python. Okay, do one thing before looking at the proper code, just practice it. Okay, I am sure that you guys will be able to do it. Okay, at least insertion deletion operation will be easily done. Okay, so first get the concept of saddle point. So saddle point is a matrix. Okay, in the matrix, if all the numbers are in odd and if the numbers are not similar, then we are going to find out that a particular number, whether it's the highest number in that particular row, and if that one is the highest one in the row, then that has to be the lowest in the column. Okay, and if that particular number is lowest in the row, that particular number has to be highest in the column. And find out each of those points. And for that, how we are going to do? If this is your matrix, this is your 4x4 matrix, you just pick another 1x4 matrix. Okay, in 1x4 matrix, just put the maximum values of each of the rows. Okay, so if you have got each of the rows maximum value, so here one condition is getting satisfied, that if that particular point is highest in the row, so you have to check only one thing, because you have already got the highest values of the row. So you have to check one thing, that either each of those numbers, not either, among all these numbers, which one is the lowest in the column. Okay, so you have got all the highest number in your rows. Okay, so now just you have to check that whether that particular number is the lowest in that column or not. You don't have to check again that whether that particular numbers are highest or not, or lowest or not, or anything. You have 20 in that, for this particular example, which you guys have already seen explaining previously, the 20 was the highest in that number. So whenever we are encountering 20, we are not going to compare each of the number with 20. We are just going to find out where is 20. Okay, we have find out 20. 20 is the maximum in that row. So now we have to check whether this one is the lowest in the column or not. If this one is the lowest in the column, okay, very good. That's the saddle point. Mark it, store there. And then we are going to come to the next one. And again, we have already found out that that is the highest in the row. So there is no need to check for the row again. We have to just go through that particular point, that R, C, and from R, C, we are just going to check for that particular column, that whether that one is the highest, lowest in the column or not. Okay. Again, if you want to switch your programming, you can again choose that of a 4x4 matrix. Take a 1x4 matrix and choose the minimum of that column. And that was row approach. Okay, highest approach, and if you want to choose your approach as the lowest one, so just choose the lowest number among that particular row. So you have got 4 numbers which are the lowest in that particular, in those particular rows. So now what you have to check, you just have to come to that particular point R, C, and check whether that one is the highest in that column or not. If that one is the highest in that column, then that's a select point. Mark it. Okay, clear about the concept?
Yes, sir.
Yes, sir.
So just do it in your home, huh? It's practice code. Okay, write down your roll number and you may leave it.